Definitely not gonna do that.
What about one thing the first time? What if you don't get the score
Where are
you
you
want?
going?
Okay.
That's
All right.
Where are you
Hey.
at now?
If I start
Okay. Oh, did I not give you
I
one?
need a Kleenex, Mr.
Okay.
Warren. Where are those?
All right. Hey, number one thing. Corner or back of the room?
Back in the room, Justin.
Or I went on the floor
Justin.
between
It's
1 and 2,
actually
but I
a
don't know if that's why.
You're
Okay.
right. Heavenly soft.
So, okay, on the graph paper, put your name. I might have you turn these in. Cool. Okay. So, put your name on it. Make sure the Y's are at the top of the page. I know some people like to go in, landscape, but make sure the Y's are at the top. Turn landscape, turn sideways.
Takes better
Can I use
pictures.
my graphic notebook?
Landscape versus portrait. That's what they call it.
I like the color.
Why goes up and down? Shouldn't people figure that out?
Yeah, they just relate. I just want. I want all the same.
I like the
I
time
have
lapses.
again.
I like slow-mo, where we
Or the
learn
pair.
that.
What is on there? You go.
All right.
Panoramic?
Panoramic.
Sit. Right on my nerves. Okay. All right. Today, what we're gonna do? We're gonna talk about transformations, intercepts versus asymptotes. The first graph, try to do the best you can at drawing this, and then we're going to talk about what happens to this graph when we manipulate it. So, first one. Okay, so this is my function.
Steve Ward.
Okay.
Cindy doesn't have the paper.
Oh, thank you so much.
I'll donate you mine.
I already tried.
Justin needs a paper now.
Okay, yeah, mine as well.
Justin needs a
He
paper.
just threw this thing. Give it back to Gemma. Okay,
Oh,
never mind.
whoa.
Oh,
You
Just in
volunteered
case,
as
try to make a graph. But
just
I might
in
want this
case.
collected sealed.
Where is
You want
Where's
this collected?
Mr. Nielsen?
I'll tell you when you need to turn it.
I'm by
Okay.
myself.
All right.
I can rip it out of here too, though.
Okay.
Who does not know that?
Hey. Okay. First.
That was pretty rude.
Hey. First. All right. The first graph here. Here's what I want you to do. We're going to start with an arrow going down. It's gonna go up. It's gonna go to -3, 2. It's gonna go down to 0, 0. And then it's gonna go diagonal to. It's gonna go diagonal to 10, 1. And that's where it's gonna stop. So again, it's from negative infinity.
I'm drawing this?
Yep. From
Okay.
from negative infinity up to -3, 2.
Okay, give me a second.
-3, 2. Then it's going to go down towards 0, 0.
Okay.
And then it's going to go diagonal where it goes out to 10, 1.
Holy
I feel like going out to 10, 1 is so extra.
Yeah. Now it's going to stop there. It's going to definitely stop. Now what we're going to talk about is intercepts. We're going to talk about what happens when we manipulate the graph, because we're going to just say that this function, we're going to put like a little name next to it. This is function f of x. F of x. Now, for the next couple graphs, you can use the other graphs on the paper. Don't put it on this picture. Does that make sense? Okay. So when we draw the next couple pictures, you're going to put them in a different grid, like a different box, different graph. You have 6.
When we,
Your neighbor has to be able to see
what
that.
is it called, manipulated?
Yeah. You're going to draw a new picture in a different grid. Different grid. Okay. All right. Ready? All right. First one.
Bullet.
I don't feel it.
Pull harder.
All right. So this should be your second graph. So go find your new graph. So second one, I don't care if you go to the right, if you go below it, but whatever your graph's at, you need to label it f of x plus 5. So this should be your second graph on your page. I would say just put that label like next to it. You can put it there. You can put it over up to the right. Your name should be on this page, because eventually I might have you wear this in. Okay. What is the plus 5 in the back? Up. Okay. So this is going to translate up 5. That's a shift. Vertical 5. So every dot here, so this should be your second graph, every dot should go up 5. So 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. And the graph should look pretty much identical.
No, stop.
But all it is it's moved up 5 locations. Okay? Next. Because I know a lot of you are still doing this. Second one. Now what we're going to do is we're going to put a 2 in front of f of x.
Holy cow.
I don't know how to do that at all.
Okay. This
Give
one.
me a minute.
I'm giving you a little bit of time to finish that last one.
Yeah, you're.
Because again, you should be on a second graph. Don't be on the same graph, be on a new graph when you're drawing that second picture.
Thank you, Mr. Ward.
Third picture, which I'm gonna wait a little bit. Third picture, I don't know where you're putting it, but we have a third picture. This is gonna be f of x with a 2 out front. All right. What this is gonna do is it's gonna stretch your graph vertically. Stretching it. So that means anytime you're not at 0, 0, or you're not on the x-axis, it will go vertical twice as tall as what it is now. So it's just stretching it vertical. That's all it's really doing. It's not compacting it. It's going straight up and down. The x-intercepts are still the same numbers. People get that wrong a lot. They try to manipulate. If you take 0 times any number, you're still 0. So that's what we're doing. This number is affecting the y numbers only coming out. So your third picture should be a modification of the one that we did originally. It shouldn't be shifted up or down. It should go straight at 0, 0. But any of these other numbers will be twice as tall. So
It'd be a goose egg.
This is cockles.
This is hard.
A goose egg?
still be 0. And whatever this point is here, I think that was 5 negative 5, 0.
I have a lot of them.
Okay, all right. So the second graph will be twice, or I should say the third graph will be 3 times as tall. It will still hit
2 times. 2
Hey, it will still hit. It'll still hit the same x-intercepts. The x-intercepts were negative 5, 0.
Oh, we
And-
marked that one? I thought it was just a random.
Yeah, I thought
Whatever yours is, leave it at that.
Well, one's 5, they're different.
So if you didn't hit negative 5 like I did, maybe hit negative 6.
I just randomly.
Okay.
I just.
You're gonna hit the same number wherever you're at now.
Oh my
Okay.
god. That's in the middle of something. That's in the middle of Egypt.
What's he talking about?
It's gonna go twice as tall. So your next grid, your next dot here, instead of at 2 high, it's gonna be 4 tall. It'll still hit 0, 0 because the x-intercepts are all gonna stay the same. It was at 10, 1, now it's at 10, 2, and here's the values. It's still gonna be here, but now it's twice as tall, so it's doing this.
Crikey, mate.
It's this.
It's almost like
It looks like the same picture, but it's being stretched vertical, so the arrow actually will cross because whatever these values were, they're now twice as tall. So even this spot right here, it's twice as far down the road. You know, so if it was like 8 here to get to that little arrow tip, it's now double that distance down here. So you gotta be careful where you're going. So now I know a lot of you said that you had a different x-intercept than I did because you drew it random. Fine, but when you double the height, the x-intercept didn't change. You still hit that same dot they did before.
I've hit a different dot pretty much every time.
That's fine.
That's terrible.
It's fine.
Inaccurate. That's inaccurate.
Okay.
I fixed my.
All right. Hey, are we okay with the 3 graphs?
Yeah.
Tomorrow we're gonna practice the other 3. Okay. We're gonna do 3 and 3. Okay. No. Okay. So the graph paper. Put that graph paper away. You'll need it tomorrow. So if you were drawing on your own, that's
So we
fine.
won't need,
We need to
I
bring
drew it on your
back,
paper
what's
because
the
I got
word?
confused.
Tomorrow.
Tomorrow.
All right.
I don't have
Next.
So
over in here.
tomorrow we'll do the next 3.
Wait, we need this?
So we'll need that. So we'll have you turn that in.
Are we done for the
What was
day?
the last time you worked?
Yesterday.
No, she didn't work. She just wanted to work.
I would hope so.
What?
Is that best?
Oh, thanks.
Why?
Okay.
Tell me happy birthday. Thank
2
you.
months.
Oh!
Why?
Shut up.
What did you get last time?
31.
Monday, so we'll be at.
Maybe which category would you have to improve on?
All right. Hey. Okay. Next. The next thing we're gonna do, we're gonna talk about composite functions, and we're gonna do calculations and determine functions. I'm gonna get rid of my graph paper here. I don't need it. All right. There's normal notes right now. Okay. Composite function. I'm gonna give you 3 functions on the board. 3 functions. I'd like to have these written down in your notes. This will be one of the types of problems you're going to have where they do a couple different things. Always.
Oh, I'm actually just
We have to do this yesterday.
All right. Next. All right. So this one's based on calculations. There's quite a few more of these than the other type that I'm going to have. The second ones that we're going to do. This one, they'll give you values to plug in or maybe variables to plug in. I'll do a couple of examples. And yeah, and what we're going to do is we're going to try to evaluate or simplify as far as we can. So for instance, maybe they're doing something like this. They're going G of H of 4. Holy So maybe that's what we're doing. That's a calculation. You're plugging numbers in. Now, how I think of this. You're going to figure out what H of 4 is first.
Then you plug that into the good.
Yep. So you're doing H of 4. That means you're going to plug the 4 into the H function. I'm going inside out.
7 divided by 2, 3.5. Okay,
so-
you're gonna plug that
I was actually gonna ask you.
4 plus 3 divided by 2.
some number times a negative 4 plus a 1. Correct.
My mouth is like numb right now.
Oh.
Do you want to go on this?
We did that workout at least.
All right. Okay, so we plugged in the 4 into the H function. Now, whatever that answer is, it was 3.5. That number, since this is 3.5, we're going to replace that. We're going to substitute it out. And so we're taking the value of this out, plugging the 3.5 that we just found into that location, because that was H of 4 was 3.5. And now we're plugging that number into G. So it's going inside one after another. So now, the G function, that's going negative 4, 3.5 squared, plus 1 squared. All right, when you do this, the 3.5 has to be squared first. So that's going to be a bigger number. And then you're going to take it times negative 4 and then add 1. You still have to follow the order of operations. So 3.5 squared.
I'm not gonna hang out.
5, 32, 17, 31, 10.
Don't come. It's just always rambling.
Stop, I'm actually.
I'm gonna ask him next.
It's 12.5.
Next semester, I'm gonna ask him what all he's taking. So
49.
I got a class.
Negative 4, or yeah, negative 49 plus.
I need to do my homework because I literally am not gonna have it.
Hey, we gotta stop talking. We gotta stop. Unless you're being constructive, we're talking about the problem, which I heard some people are. Let's stay here. Okay, otherwise, I don't need the random conversations. I can't hear it, I don't like it. Okay, all right. So we got negative 48. That's the number I'm looking for. That's the final value of these problems. Now, they will have digits, like this problem, or they'll have variables. So you gotta be careful. If they want you to do variables, you're doing the same stuff, it's just you can't simplify it that far. So if they did a problem like this, maybe they did, and I'm gonna write this a little bit different. Maybe they go G of F of the letter M. And they write it something like that, where they're using the little circle method. What this means is they're doing this. You're plugging F with the M plugged into it, or whatever that value is, whatever this simplifies to, that's going to replace this part right here, and then you're going to take whatever that answer is and plug it into G. This can get messy, especially if I'm plugging M into the F function. Here's what I'm going to get. So I'm going to figure out this part first. Plugging an M into the F function, I get this. N plus 2. Then, I'm taking M plus 2 that we just found, that I just replaced, and that's going into G second. Well, that's going to be negative 4 M plus 2 squared plus 1. And they want you to simplify it. So that means you don't distribute, you FOIL. Because the power of 2 on a parenthesis like that means you have 2 of them, and you have to multiply those together. The most common mistake people make on this assignment, I guarantee it's got to be this thing right here. They'll try to distribute the 2, they get it all wrong, and they're like, "Oh, that's the law of exponents." It's the law of exponents if there wasn't a plus sign. If there's a plus sign, then you have to do the FOIL technique. 2 parentheses, multiply together. It will want you to go through the whole process of doing that. They're not going to be big numbers, but you got to be ready that they're going to have variables for you. Questions, comments about that problem? the last example I want to do of this composite stuff for the calculations. There was one problem in the book I saw, it did something like this. This is what they had. G of x plus 1 plus f of 3.
Hey, that's vandalizing.
Alright, so this problem, this is my last example for the calculation stuff, then we'll do the second one. They're having you do two different things and then add the results together. So you're going to have to find this answer separately, find this answer separately, and whatever the answer is, you're going to add them together.
Okay.
The x plus 1 idea, whatever that is, that's going into this function, so wherever there's x's, if there's multiple x's, those will all be replaced. So what we have is we have this.
Can we change that J to an H?
No.
We haven't been using
I don't,
H very
I don't
much.
know.
No.
Okay, so I plugged in the x plus 1, I have the f of 3, that's the 3 plus the 2 here. That's your f function, and you can start to simplify and go from there.
I don't know.
Questions, comments about what they're going to ask you for?
No.
Okay, that's all the calculation stuff. Hopefully that stuff made sense. Again, it just requires calculators, make sure that you're following the right order of operations. I do want you to show work when it's necessary, like foiling, you should be writing some stuff down. Some people are pretty good at doing it in their head, but I do want you to write some stuff down when you're doing the answer.
You know what, Mr.
Because
Ward, I have
they
this
can get
one.
kind of messy.
You'll have that.
Mr. Ward, I have the answer to that last thing you just did. Can I tell you?
Boy, you gotta add that.
Negative 4x squared minus negative 8x
Minus 8x
Some
minus
things are worse than
8x
others.
minus 4.
plus 6, so plus 2.
Okay, all right. We're good with that one.
Yeah.
Next
It
one.
was negative 4x squared minus 8x plus 2.
Okay,
Just play for
now I'm done with the calculation stuff. Here's the next part that I want you to look at. This is the one that I think I started with yesterday, was this. G of x is x plus 2 to the third power. And what they want you to do is determine the parts of this composite function and write it down into individual functions.
What?
So,
Oh yeah, this is the tricky one.
to determine the properties, here's what I want. We're going to pick a different letter of the alphabet. So I'm going to pick
Q.
Q. Fine, I like Q.
Z.
So Q of x,
This guy's gonna be a lot of notebook space.
Dots.
Q of x is going to represent my x plus 2.
Okay.
That's going to be Q of x. And what I'm going to do is I'm going to take out this and replace it with a Q of x sitting in here. So this is Q of x to the third power. Does that make sense?
Yes.
So, what they want you to do is to figure out what the original function should have been. The original function, whatever the variables are, it was probably g of some other letter, let's call it g of z. G of z was a z cubed. That's what it originally was. That was the original part. So what they did is they took out this term right here and they replaced it with that. So they went q of x is an x plus 2. So these are the two parts that they are putting together. The problem that they were trying to make was this. G of q of x. That's the problem that they're trying to make. That they're plugging q of x, this thing, into this problem.
Oh.
So what we did is we figured out what the composite function was and what the parts are. Does that make sense?
No.
Okay, you just randomly used a Z and you just.
Yeah. So Z is just what the original overall problem should have been. It's like the outer layer. You can pick any letter of the alphabet as long as it's not the original letter that was in the problem. Okay, so if you have X, use a Y. Or if they have an M, use an N.
I get using
And
different
then
letters, but I don't get what you're
the
doing.
Q is the other name of the function, the second function. The main function is G. The second function is Q.
So we're just making up stuff.
Not making up stuff. You're trying to break it down. This is what they give you, and they want you to break it down into what its two parts were.
Does it tell us what the two parts
No,
were?
that's what you're trying to figure out. You're trying to figure out the two parts by looking at that problem. That's the thing they have printed in the book for like number 12. And so they go, okay, the overall problem is
Is
this.
that a 2 there? X plus 2?
Yeah, that's x plus 2.
Okay.
That's the part that they're plugging into this to make that function. So you're just like breaking it up.
Are there several different answers for that?
Yes, that's the thing. There could be more than one thing depending on how you looked at the problem, how you broke it down. Maybe you factored apart and you saw something else. So there could be, because you can use different letters of the alphabet than somebody else would. But more or less, they'll pretty, because I'm only assigning super easy ones, they'll all pretty much look the same.
What do you have to change that to?
Oh, definitely.
C of x equals x plus 2? Then if you, no, second one.
No, because this is just a variable I use. So this is the function. This is like one of the parts, so whatever z is here that we plugged in here, well, that's gonna be taken care of. Because this is what the problem is, right? They're taking q of x, which is this thing, and they're taking whatever that is and plugging it in here. So then eventually it turns into the right item.
I'm a dumb one. I'm a dumb one.
Yeah, I don't know how to remember.
Literally, that's why I dropped.
I would say like, given this problem, determine the function. These are the functions. I know, it's just weird, just going back.
Wait, nobody raised it.
Just raising the parts of Alright, hey, last parts today, last parts. We're talking about inverse functions and talking about evens and odds, okay? Alright.
I'm gonna also go for That's cool.
Okay, last thing.
Mine was like 1 or 2.
It's weird.
Alright, last problem here. Okay, hey, alright, last part. We're gonna try to determine whether we have an inverse and whether the function's even or odd. So,
Horizontal line.
okay, let's use h of x, and let's call this x cubed plus 1. Alright, on this problem, if we were to graph this, on this problem, hey, you gotta stop talking. If we were to graph this, we'll be able to easily see whether it has an inverse or not. I actually recommend that you do that. So tomorrow, when we have homework, you want your Chromebook so we can type these functions like that into Desmos and see what the graph looks like. This function, if you were to type it in Desmos, it'll look like this.
Not really, I don't really.
That's what it's going to look like.
What? Okay. When is the one that we do?
Monday.
Wait, we're not getting it today.
No, get it tomorrow.
Which game?
Okay.
All right. Now, if this is my function, if that's my function, you do the horizontal line test to see if it actually does have an inverse. If you do it anywhere on this graph by a horizontal line, it only hits the graph once no matter where you're at. So yes, this has an inverse. Now, the book does not ask you to go find it. Fine. Because some of them can be difficult. The problems I'm going to assign will be easy to calculate the inverse. So there's going to be only a few that you're going to have to do that. It's a yes/no question. You'll have to go find it. But the book has like some crazy difficult ones that you have to graph and kind of look at. I'll only assign easy ones that you can actually find the inverse if you're going to do it the old school way of doing it, where you actually switch the letters and you just do it by yourself without having to type it in Desmos. Yeah, where you don't like graph it.
What's the new school way?
Graphing.
Just to work
Just
with.
go graph it.
Why is that new?
Well, because you're using technology to do it, not by hand.
Graphing's been around for.
Yeah, but you're not setting up a
Centuries.
table.
You know
you're
your
not doing
cell
like
phone's based
plugging in
on X, Y,
different
D
values. So, all right. Now that you know this, it does have an inverse. That's yes, it has an inverse. Okay. The next question:
Is it even odd or
even,
neither?
odd, or neither?
Right.
To check that, that's where you take your function and you plug in a negative x into the function. When you plug it in, so I'm going to take that function, plug in a negative x in. If the function turns out to be exactly the same function, like it cancels out the negative signs, it turns out to be the original thing you started with. It's even. This one, well, does the negative sign go away? No, because that's not power, right? So it'll keep the negative sign on the outside, like that. Is this the original thing you started with? No, so it's not even. Is it the exact opposite of that one? No, because that would have negative, negative. So this is neither, it's neither. this is neither symmetrical.
Neither
Now,
nor, either
why I
or.
know it's not symmetrical.
Those are a pair. Because the tails.
But neither, it's not symmetrical. The reason why, when you look at the picture, it's not balanced over the x-axis or the y-axis.
Oh, there's only one.
Because when you see it, the values over here are not matching the values over here along the x's. They're not. If I were to go to like the number 1 down the road, that might be different than -1 right here. They have to have the same values to be symmetrical, either even or odd. They either have to be the exact opposites or the exact same digits. They're not. So I can tell you by looking at the graph whether it's symmetrical, like even, odd, or neither. Even symmetrical problems, you can definitely tell this is neither. Even symmetrical problems look like this.
Neither nor, either or.
What do all look like?
That's an even function.
It's symmetrical.
They're exactly balanced. Even functions
It's like a
don't have
mirror.
inverses. So that's pretty easy to see that. If it's an odd function, now the odd function will look really close to that picture,
Yeah, got it.
but odds will look like this. They'll be perfectly balanced over 0, 0. Like
Like a
where
sine
it's
graph.
just doing the opposite,
Like a sign.
like a sine graph.
Okay.
Or anything that's happening. It could be anything, but whatever's happening over here, there's an exact mirror image on the other side of the x-axis and the y-axis. Like it's diagonal from each other.
So y-axis is even, x-axis is odd,
Yep.
and then
Neither, it's not the same on the right and left side.
Hey, what's up? This is
Okay, questions, comments?
No.
All right, we are done for the day. Make sure the graph paper I handed you comes back tomorrow. We're gonna do 3 more graphs on there to practice. That'll be something you will be turning in, because I'll give you points for it.
There's a ward. Maurice needs to tell you a joke.
Ward, I'll be gone
Do you
Friday.
know how to keep an idiot in suspense? Do you know how to keep an idiot in suspense?
I remember when Brian did that.
What did you say? Nothing?
Yeah, he said nothing, so he like asked me, no, tell us. So, it's like literally like that.
I can see Brian.
How do you keep an idiot? Like, you know, be quiet, and so they ask you, what's the answer, and how's the thing? And there's no answer.
That's like he'll tell you tomorrow.
Like last year.
Yeah. He said, I'll tell you tomorrow.
Presentation on nuclear energy. Remember his presentation on nuclear energy? He was wrong.